So this is getting recorded. This is chapter number 6, discrete probability distribution. And chapter number 7 is about continuous probability distribution. So now you can understand the meaning of discrete and continuous. You can relate those concepts that we learned in chapter number 2. What is discrete? What is continuous? So we are going to apply the discrete concept here, because we are going to see the probability of event 0, 1, 2, 3, any event more than, less than. So we are just dealing here with a discrete number. Therefore these probability distributions are discrete probability distribution. Okay. What we have: uniform distribution, binomial distribution, Poisson distribution, hypergeometric distribution, geometric, and so these are the distribution we are going to cover in this. So probability distribution, let me start with a very simple example about what is the distribution. If I take an example of let's say in my class, undergraduate class, I have 4-year students, year 1, freshman, sophomore, junior, senior. Let's say I have a 4-year students. In each year I have, let's say, 25% students of first year, or second year 25, third year 25%, and fourth year 25%. I have to write decimal in decimal form. So what is this distribution of all 4-year, 1 to 4 year? This is uniform distribution. Uniform distribution because every year means every year, or every junior, senior, sophomore, freshman, they have equal or equal distribution of the students in my decision science class. Therefore this is distribution. Similarly, you can think about distribution in any form. So this is a very simple example of uniform distribution. Distribution of the a discrete probability distribution assign a probability to each value of discrete random variable. So this is the probability of any event is 0. It can be 0, it can be 1, and it is between 0 and 1. The total event probability is 1. That we know. The entire, this is my probability of my class is 1. If I sum all them, this is going to be 1. Let's have a look of this example. Let's say you are going to flip a coin. You have 3 coins, and 3 coins. What are the possible outcomes in 3 coins? If you do 3 coins, if you toss 3 coins together, these are the possible situation. Either it can be all 3 head, 2 head, 1 tail, 1 head, 1, this is first coin can be head, second can be tail, third. So these are all possible events or possible. Look into this. So probability distribution of 3 coin flips. Here possible of event, no head. Look into the head. What are the possibility of no head? This is the situation where we don't have any head. This is the at least 1 head. Here these are the 3 situations where you have at least 1 head. 2 heads means these are the events. 2 heads, you have 3 situations where you have 2 heads. And the third all head, all 3 head, you have 1 situation. So what is the event probability? So probability of getting no head is equal to 1 divided by 8, because the total number are, how many cases are there? 1, 2, 3, 4, 5, 6, 7. Total are 8 events. So this is 3 by 8 event, 3 by 8 event, 1 by 8, and this is total probability is 1. Now here you can see this is discrete distribution. Why? Because you can see the event. Either event is 1, event 2, event 3. We don't have any event which is 1.2. We don't have any event which is 4 or 0.05 or 0.5. We are not dealing in decimal, only 0 to integer or discrete numbers. So therefore this is called discrete probability distribution. Next chapter we will deal with a point or decimal values too, that is called continuous probability distribution. So this should be very clear, because we are going to deal with only discrete numbers. So if you plot this, this probability, here it is, event 0. What is the probability? 1 by 8. Event 1. What is the probability? This is event 2. This is the probability, and this. So this is the probability distribution of flipping 3 coin and having head. Now there are two types of probability distribution. One is PDF, another is CDF. So it should be very clear right from now what is PDF, what is CDF, because we have a lot of PDF and CDF things. One is probability distribution. So look into this is a probability distribution. Event 0, event 1, event 2, event 3. So this is probability distribution. Now cumulative probability distribution. Cumulative probability distribution. So this is 0th. On 1th event, you will have 0 plus 1. On 2th, you will have 0 and 1 and 2. And their third, you will have all previous, at last, you will have 100%. So look into this. So this is, for example, a probability distribution of any event or any, discrete probability distribution. This is cumulative. Cumulative is the last bar or last, column will have 100% of one probability. You can see against this is 100. So it it counts the value of all previous, events. So for example, if this is the event, event number 7, event 7 has the value of 6, 5, 4, 3, all these previous values are added into this, and that's why we have, and this is the last, for example, this is 1. It has all the values of previous events or all the values of these previous events. This is cumulative. Please interrupt me if you don't understand anything, because this is really, little complex chapter. Now we have another concept, expected value. Expected value is probability event and probability of event. Ex equal to mu, and this is expected value is equal to xi or pxi. So we can just look into this. Here you can see event. These are for example, these are the events, event 0, 1, 2, 3, 4, 5. And this is relevant probability there, probability event 0's probability is 5%, 1 probability 10%, 2 30%, 3, and total probability is 1. So xpx is 0, this multiplied by this. What we are getting here? 2.75. So event x equal to 2.75. This is called expected value. So this is expected value. So mu, or this is also denoted by mu, 2.75, and if you plot these things, you can see this is, so the mu or expected value is here. Variance in the standard deviation, like we studied in chapter 4, this is, so you just understand the meaning of standard deviation and variance, and this is expected value or mu. So these two are going to be very important, uh, uh, statistical tool. Mu means mean, and standard deviation in order to calculate any probability distribution. So this is exactly, this is a calculation for getting the variance and the standard deviation. So we don't need to do, because we can get all these numbers automatically. Now we are coming to very first distribution, which is called uniform distribution. When do we use it? So what is the best way in order to do this chapter? First, you understand the difference between uniform, binomial, Poisson in all these distributions. First step is to identify which is the distribution is there in the question or situation. Then you just use the Minitab to do the answer. So first thing first is finding the distribution. So uniform distribution, as you can simply understand, I gave the example of my, a class 25% or in 25 in each 4-year student. We have, so that is uniformly distributed. So uniform distribution describes a random variable with finite number of integer values from A to B. Each value of random variable is equally likely to occur. Here, for example, you will see in each distribution, this is summary of distribution. So for example, look into this. Parameter A is lower limit, B is upper limit. Probability distribution function, PDF, cumulative distribution function. This is formula of PDF, this is a formula of CDF. This is a mean formula, this is a standard formula, because in each distribution, these PDF, CDF, mean, standard deviation, these will change. So this is so first question is here, rolling a die. You have 6 phases in die, and all 6 are equally likely to occur. So if you roll a die, these can be the possible 1, 2, 3, 4, 5, 6. And this is a probability distribution. This is a cumulative probability distribution. So what is the 1 by 6, which is 16.67. 16.67, 16.67, and all together this is 1. So first one is 16.67, the second is 33.33, next is 50, the another is 67.67, then go ahead, and finally is 1. So this is PDF and this is CDF function. What is the mean of this? If this A plus B divided by 2. So first event is 1, the last event is 6th. 1 plus 6 divided by 2, which is 3.5. So its the mean would be between 3 and 4. It is standard deviation. If we calculate all these numbers, putting B minus A, 6 minus A plus 1, and doing all, we can get a standard deviation. So rolling a die, this is the situation. Its mean would be this, its a standard deviation would be this, its a PDF is this, CDF is this. So this is, we normally don't use the uniform distribution, is, really or practically not that applicable. But now we are coming to the very important uh, distribution that is highly applicable, that is highly useful in managerial decision making. Binomial distribution has two outcomes which are exactly opposite of each other. Let's say today we will have a class. Today we will not have the class. Let's say tomorrow it is tomorrow there is a 60% chance that rain will happen, or it may rain, 40% chance it may not rain. So basically the binomial distribution, whenever you see a situation where two kind of situations are there, success or failure or yes or no, then we are going to use binomial distribution. Only two, situations. So this is binomial. A random experiment with only two outcome is binomial or Bernoulli experiment. One outcome is labeled as success, another is failure. If, for example, we are going to have a class tomorrow, there is a 60% chance. Then what is the chance that class will not happen? 61 minus 60%, 40% chance we will not have the. Tomorrow you will go for oil change of your car, 90%. Okay, there is a 10% chance that you will not go for oil change of your car. So you might visit a bank, 50% chance. You will not visit a bank is 50% chance. So basically pi is a, always remember binomial distribution has two outcome. So success is defined as the less likely outcome, so that pi is less than 0.5 for convenience. So in many cases this is, so probability of 0 plus probability of 1 equal to probability of 1 minus pi plus pi equal to 1. So the pi is between 0 to 1, or it can be 0, it can be 1 also. What is the expected value in this? And this is expected value is pi. So here is the binomial distribution. I mean, this is just to read here. Look into this parameters and number of trials. Okay. Pi is a probability. So what we need in this case, this. What is a PDF? This is a PDF function. We are not going to remember all these equations or formulas. We are just going to work on Minitab to get the answer, to understand the question and get the answer. Mean is n and pi. N means number of trials. Pi is, ratio or, probability, number of trials and probability. Standard deviation is n pi 1 minus pi. And this is PDF and this is. So look into this case. It is important to quick while change soft to ensure that a car service time is not considered late by the customer. Service times are defined as either late or not late. So basically here you can see clearly late or not late. These are the two situations which are defined. So this is a Bernoulli's. So here, what is the probability that exactly 2 of the next 12 cars service are late? Here car late is 10%. card not late is 90%. So instead of doing all these things, here we have n out of 12. We are taking a 12 cars and we are looking exactly 2 cars. The pi is 10. So very simple. I'm just using Minitab. Here, can you see the Minitab? Status under Minitab, we have
Yes.
calculator. Under calculator, we have probability distribution. Under probability distribution, we have binomial. Now, the question is, which option do we need to use? So we are using only simple probability. We are not using, this is PDF, this is a CDF, and this is inverse CDF. So these are the 3 options. We are just using as of now PDF. And I will, how many trials are there? Number of trials are 12. Event probability is 10%. Input column or input constant is 2. And we are just, number of trials are 12. Look into the question I am going to show. Next 12, exactly 2. We are going to look the probability of exactly 2 of next 12, where pi is 10%. So just I'm going to use this. Number of trials are 2, event probability is 10%, input constant. So if you can see my binomial, and now you can see the probability of this is 23 point same. Can you look into this? If you understand this, let me go and explain to you in this way also. Look into this. This is, number of trials are 12, event probability is 0.1, and we would like to see the x value, probability value. X value is 2. Now, left tail, right tail. Okay. No, this is just binomial. 12, probability is 1. So this is a, here you can see, this is the total probability distribution where event is 12, n is 12, p is 0.01. So this is the probability of event 0. That is 28. Event 1 is 37. Here event 2 probability is 23%. Here you can see. And now I am going to demonstrate this using one more way, which is classical way that I learned in my student time, during my student time. Here is the classical way of doing this. We have a table, and every book that you have is all, every statistics book has this table at the bottom of your. Look into this. Can you see the table? And here you can see this is on this side. These are the probabilities here. You can see the pi values are here. So what is the, in our question, what is the probability is 10%. Look into that. Now here we have n values. So look into the n values. We are going to check the n values. So n, 11, 12. And x value, here we have x value. So 12 we have a, this, and x value is 2 for us. And now we are going to look, this is 10%. So if I'm So look into this is 10%, n is 12. This is our answer. Can you see? This is exactly 23.1%. 23%, you can see.
So I'm still confused on how you're getting the pi number, the 10%.
The 10% number is given in the question. Is given in the
Okay, so
question.
we never have to just figure that out. That came from the question, so we'll never have to figure out pi.
Yeah, so pi will be given in a question, and that you have to solve it. So yeah, you don't need to calculate.
Okay, thank you.
Yeah, so this is, so the question, what is the probability that exactly 2 of the next 12 cars serviced are late? And the answer is 23%. If I ask the same question, what is the probability that exactly 1 of the next 12 cars serviced are late? And we can do the, I think it was coming in Minitab. This is the answer, 37.65%. This is the answer, 37.65%. What is the probability that exactly no car, here rate me, what is the probability that exactly 0 of the next 12 cars serviced are late? And that would be, this is 28.24%. So this is, and you can get exactly from Minitab, you can get exactly from table. So all the methods are applicable. Look into another case. On an average, so here is the question. On an average, 20% of emergency room patient at Greenwood Hospital lack health insurance. So this is, how do we get these 20%? Basically, based on the empirical analysis. And for example, in America there are 5% people are uninsured, or many statistics that you get from National Statistics Institute or government data. So basically, based on this, 20% of emergency room patients are uninsured, lack health insurance. Okay. If they take a sample of 4, randomly, so this is a statistics in as hospital. They go and take the sample of 4 people or 4%. What is the probability that at least 2 will be uninsured? At least 2 will be uninsured. So here is the question. Now, how we get the answer? So I just remove this part. At least I just remove this part. First, we are going to answer in a random sample of 4 patients, what is the probability that 2 will be uninsured? Okay. Let me use the same thing. I'm going to do calculate probability distribution binomial. Here we have number of trials, how many we are doing, we are catching, or we are just going to get sample of 4. Event probability is 2. Input constant is 2. I just removed the word at least. What is the value we are getting? 15%, at least 2. Now we are going to get the, we would like to know the at least 2. Here we have the compound event probability. Compound event probability is very important to be understood. So here n range is, what are the range? 0 patient uninsured, 1 patient uninsured, 2 patient uninsured, 3 patient uninsured, and 4th uninsured. So look into that. I'm just going to draw a graph, probability distribution. Okay. And I think number of trials are 4, event is 2. Okay, here we go. Now it is asking at least 2 are uninsured. That means it is asking 2, 3, and 4. It is asking not only, it is not asking these two. So this plus this plus this. And sum of all three will be compound, the probability of the or answer of the question. So I think better I will explain in this format. So what is asking? At least 2. Remember here always we get confused and the students make mistake here. At least 2 means 2, 3, 4. These are the possible outcomes. So it will have probability of event 2, probability of event 3, probability of event 4. So this is 15%, this is 2%, this is this. Total probability is 18%. What is the total probability is 18%. So here we go to compound event probability. First understand this. This is the most important slide in order to understand the compound event probability. Let's say there are two ways to do this, and we all for a compound event probability we always use CDF function. What we use? CDF. So I'm just going to demonstrate later. So in 4 cases you have 4 patients, 0, 1, 2, 3, 4, and this is, so if I ask at least 2 means it is asking at least 2 means whatever 2 and whatever is all above. So how do we get this? There's two methods. One you do probability of event 2, one you do probability of event 3 and 4, and then add all three to get this value. Or there's a second thing, use CDF function, do the probability up to this event, this level. So if you do probability of event 1 and subtract from 1 because total probability is 100%, 1 minus 1. So if you subtract this part from 1, you will get this part. So this is method that we used to do in our calculation. Now it is asking fewer than 2, that it is not counting 2. Less than 2, so in discrete values, what is the fewer than 2? This is the value. So 0 and 1. So if we are going to do this thing. We are not going to put x value equal to 2. Fewer than 2 or more than 2. So this is fewer than 2, more than 2. It is not asking again 2. It is asking more than 2 means this part. So compound event probability has, now we are going to do, and compound event probability we always, whenever there's a question related to at least, fewer, more than, we always use CDF or cumulative distribution function. So please remember this. Now the question is this, I'm just going back on the question. What is the probability that 2 will be uninsured? Oh, okay, I have to do this because at least 2 will be uninsured. So I'm just going this, I'm going on my calculate probability distribution binomial. Now here I'm just going to use cumulative function. Number of trials 4, event probability is 2, input constant I'm going to put 1. Why I am putting? Because I can subtract 1 from the rest of the value. So we are getting 81% if now, so this is up to 1, and now we subtract 1 minus 81%, 81.92, we are going to get 18%, 18 point something. So this is another way in order to do. I can just demonstrate also. I'm late trying to do using this also. Very two parameter view probability. Okay. So this is number of trials are 4. Event probability is 2. Shaded area, we would like to see X value, which is 1. And we want this right tail. Yeah, this we don't want. Let me see. So it gives the probability distribution. So up to this one, it is 81.9%, 92. So this is the rest of, this is probability of 2, 3, and 4. So this is, I think cumulative is better. I'm very much, I have practice on this, getting the number on this. So basically, this is the best way. You can get up to 1 and then subtract from 1. So here you can see. So either you can do for probability 2, 3, 4, or you can do up to probability 1 and then subtract from 100%, or 1, then you can get rest of the value. So it is 3 steps process, and that is 1 step process. So we use CDF function in this. What is the probability of fewer than 2 patient? Fewer than 2 means up to 1. Fewer than 2 means up to 1. So what we need to do? Fewer than 1, fewer than 2 means probability of 0 and probability of 1. So you just do probability of 0 plus probability of 1. Instead of that, you just use compound event probability and do up to 1, which already include the probability of 0th event, and you get this number. What is the probability at no more than 2 patient? No more than 2 patients. So this is asking up to 2 patient, which include probability of 0, probability of 1, probability of 2. And if in this case we are going to have this, which is 97, and we can do using this case. So input constant is 2, exact rest is 97.28%. So right here we are getting the exact value, 97.28. So in compound event probability, whenever it is asked more than values, more than anything, or we always subtract from 1. If it is asked up to that, we don't subtract. So in this case, we are not going to subtract. But if other case, in this case, for example, we are going to subtract. Is it making sense? Because this is important to, if this is clear, then I can go ahead.
It makes sense to me.
Okay, thank you. Yeah. So Minitab, yeah, also actually, look into the table. This is a table. Here you can, n values, look into the where we have the, we have the, I think up to n equal to 16. That means if you do the number of events, or n is greater than 60, or 16, or you reaches to higher sample size, that means higher the sample size, it approaches to normal distribution. Therefore, we don't have the binomial distribution. So 16 or higher it will be. And you can also, if you are interested, you can do manually. Means what is the case? We have n equal to 4, and the probability, what is the this is the case, this is the, look into, let me get this. So this is the case of that we are going. This is the event 0 probability, event 1 probability, event 2 probability, event 3 probability, and 4. Now you can do the adding. So if it is asking fewer than 2 means up to 1. So you can add these two probability, 41 and 41, which is almost 42%. It is asking at least 2 means you can add this, and this. So which is coming 18.1% that you can see. So you can also, without using Minitab, you can also look into this. So this is a binomial distribution, and this is the application we have. So whenever you have, empirical pi value, or, probability value, and then you are going to take the sample, and out of the sample you are going to check that how many people, what is the probability of any event. Let's say since we work in Eastern Washington University, let me frame a question and we can see the real application of this. And so let me see that traditionally on an average, based on past records in almost 7% alumni donate the money to EWU alumni meet event, or so there's an event on XYZ date, or let's say October 25th, 2020, where 100 where, let's say class of 1990 is coming, or classes 1990 reunion is taking place. And if you take sample of 7 out of that, sample of, if you take sample of 20 alumni, or 20 is bigger because we have 16, out of which it becomes normal distribution, that I will, so just keep the number sample is less than 16. So I'm just going to take a sample of 12. If you take a sample of 12 alumni, what is the probability that third alumni will donate? This is my question. And do you have Minitab in front of you? Can you tell me the answer? if you have Minitab in front of you, so first question is this. The second, more than 3 will donate and fewer than 5 will donate. These are the three situations, and I need your answer. Sorry, past I misspelled. Do you have Minitab in front of you? If not, I will do this. If you have, you just try to do this. So basically, you know, probability, most of the probability is used based on, you know, many decisions which doesn't have much information based on, you know, there we always use probability.
So is the answer to the first one point, or I guess be 3.9%?
I have to do it, you know, 3.9%. So let me do it for you. So I go here in statistics and sorry, calculate, and I go to binomial and look into this. So number of tries, how many I'm going to take, 12 alumni, event probability is 0.07, and we are checking for exactly, but we are using simple probability because that third alumni, and this is the answer. What is the answer? So I think this is your also answer. So we are correct. 3.9%, which is correct. Or you can say roughly 4% is the chance third alumni will donate. Now, more than 3 will donate. So what is the probability for this?
Is that just 1 minus the probability that we just
Yeah.
determined?
So more than 3 will donate. So, you know, no. So more than 3. So this is a cumulative function. So we have to do up to, or we have to do more than 3 means probability of 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have to do this. Otherwise, what we can do in cumulative function, we can do up to 3, more than 3. So let me go and do this probability distribution, binomial. And now here, if you can see my screen, and exactly I'm just changing probability to cumulative one. And now I'm going to do up to 3, and then we subtract from 1 and we can get the answer. So how much? This is the 99 points. So this is up to 3, and we are going to find more than 3 people will donate out of 12, so which is less than 1%, which is 99.24 percent. I would say 0.7%, 0.07. How much? Yeah, 99.24, which is, yeah, 0.7% approximately, or 0.75%, less than 1%. So up to 3 is this, more than 3, because you know the event, you know, this is only 7% alumni donate. So what is the probability that more than 3 will donate? Fewer than 5 will donate. So fewer than 5, it is not asking 5. So here, you know, more than, in more than we always subtract with 1. Less than we don't subtract, we get the value. So I go stat, sorry, calculate probability distribution, binomial probability, and now fewer than 5. So we are going to do up to 4. So this is always tricky to add the input constant. So if it is asking fewer than 5, we are going to have 4. And if it is question up to 5, then we are going to have 5 here. Now look into what is the probability, 99.9, which is almost 100%. Is it making sense? If yes to all, I can go ahead and proceed further. And now, if you understand this, the next things are, simple. And let me clear this. So the next distribution is in this Poisson distribution. So remember this. How do we distinguish this distribution? Poisson distribution describes the number of occurrences with randomly chosen unit of time. Example, minute, hour, month, day, week, or any flow of time. So let's say I'm giving an example on Seattle airport. Every hour, every hour, 50 flights take off and land on runway, or every hour 50 flights depart. On any bank or any messy store on particular time, 20 customer on average 20 customers arrive. Or any EW student services, on a given day, average 20 students comes 20 students come or visit. So basically, if you get such kind of situation, we always use Poisson distribution. No. So this is the important one. So how do we identify? Whenever we have such situation, we always use. Look into this. So here only lambda is important parameter, and which represent the mean number of events per unit of time or space. So many examples are there. Let's say on particular store, these many on a average hourly 20 customer visit or arrive, or on in call center 1-800, on average 20 complaints are reported. On police station or 911 number, on average 20 calls are there in a spoken. So think about such kind of situation. So here this is again summary slide of distribution. PDF is this. Its mean is lambda, which is average. Standard deviation is again square root of lambda. So if you know average, do the square root, you get the standard deviation. This is a formula. PDF, CDF, all these things are there. Look into the question. So on Thursday morning between 9 a.m. and 10 a.m., customer arrive and enter the queue at Oxnard University Credit Union at a mean rate of 1.7 customer per minute. Using the Poisson formula with lambda equal to 1.7. So lambda is given 1.7. Find the PDF mean and standard deviation. So I can see the PDF later. Mean, what is the mean? Mean is 1.7. Standard deviation is square root of 1.7. So mean is 1.7, square root of 1.7. PDF is this. Now look into that. Cumulative probability can be evaluated by, what is the probability that 2 or fewer customer will arrive in a given minute? Average is this, 2 or fewer. So let's see. Again, I go on calculate. Under calculate, we have distribution. In distribution, we have Poisson distribution. Look into this. This is Poisson distribution. What is the, again, probability or cumulative? So this is asking 2 or fewer. So this is cumulative one. Mean is 1.7. input constant 2 or fewer, so it is asking up to 2, and we can get what is the probability, 75%. And here you can see, oh, this is 75%. What is the probability of at least 3 customer? At least 3 customer. So 3 customer means 3, 4, 5, 6 all. So what we are going to do? We are going to calculate up to 2, and then we are going to subtract with 1. So already calculated up to 2, and 1 minus, so 1 minus this value, which is 24%. Is it making sense? So this is a Poisson distribution. And so Poisson's distribution, this is also the Poisson, this is a rule that you can remember. Use the Poisson approximation to binomial. You can also do this, n equal to greater than 20 and pi is less than 5%, then you can replace binomial to Poisson approximation to binomial. So don't think about this, because it will make life more difficult. I don't so this is situation. Look into the the table. Where is the table? So this is a Poisson distribution. Can you see this? What is the important factor in this? Lambda, or mean, or average arrival. So this is the these are the lambda values. You can see these are the lambda values. Up to what level lambda goes? Look into the table. Lambda goes up to 20. Can you see up to 20? Lambda value is up to 20. And these are the corresponding event x values. So what was the value what was the question that we were having? Lambda is 1.7. So 1.7 is this. And what was, the question was exactly 3. I think I forgot, So for example, these are the values of each event. Now you can subtract, add. So if you have issue, you can use this table also. If this is clear, let me go further. Third is, or fourth is, hypergeometric distribution. This distribution is useful when you have population number, when you have sample number, when you take the sample out of population and you have the things. So hypergeometric distribution is similar to binomial distribution. However, binomial, here sampling without replacement from finite population. So here, we consider the finite population, and which is always given. Whenever you see the finite population, then use hypergeometric. So look into this. This is formula summary, or the distribution summary. N equal to number of items in the population. Let's say in Eastern Washington University, there are 20, or let's say how many directors are there. Let's say 20 directors are there, or 10 directors are there, and we are going to see 5 directors sample size. Number of successes in population. So S is number of success, and then we are going to use so this is n pi. Mean is this, standard deviation is this. We are not going to look into this. So example is damaged iPod, and in a shipment of 10 iPods, 2 were damaged and at 8 are goods. So 10 iPods are shipped and 2 were damaged. The receiving department at Best Buy tests a sample of 3. So the sample is 3 iPods at a random to see if they are defective. So how many iPod? N is 10. They check 3 iPods. There are success, is 2 because 2 were damaged. So this is X is number. So we are just going to use the, this number of non-damaged iPod is 8. So here this is not binomial problem because pi is not constant here. What is the probability of getting damaged iPod on the first drop from the sample? So pi is, so just look into this. Question is, look into Minitab. So I go again, calculate probability distribution. Here we have hypergeometric. Look into hypergeometric probability. Here you can see sample size 10, event count in, and this is capital. This is how many these are, the 2. Event constant, I'm just going to do for 1. So this is the probability 46%, that if you take a sample of 3, what is the probability that it is damaged? 46%. So binomial distribution. So here you can see, this is what is the probability of 0 event? 46%. What is the probability of first event? 46%. 2 will damage this percent. So you can again do less than, more than, and so on and so forth. So this is hypergeometric. Hypergeometric, you have finite population given. So now after that, another important thing, geometric distribution. Geometric distribution, when it comes, number of Bernoulli trials until first success. So X is number of trials until first success. When it is applicable, remember, it is like a binomial distribution, but it is depend on until first success. So pi is constant probability of such. So here this is the mean and standard deviation. At a university, 15% of alumni make a donation or place during the annual telefund. Okay, what is the probability that first donation will occur on 7th call? So this is 15% chance that they are donating. Alumni, what is the probability that you will get first first donation on 7th call, first donation on this, or like you are trying for some very difficult exam, and what is the this is a success rate of the people like you, and what is the probability that first attempt you will get success, or you are hitting a like a baseball, or you are hitting a shot, what is the chance that on second attempt you will hit for that? So here pi is this is how do we do? Look into this. Here, oh sorry, Minitab and calculate, and probability distribution, we have geometric. Where is geometric distribution? And again, probability, event probability is how much? 7. What is the event probability? 15%. So 0.15. Input constant is 7th. And look into this. What is the 5, 6? This is the, so on 7th call, they will donate is 5% or 5.66%. So this is exactly here we are getting. So this is related to geometric. So the best not to confuse you, just make a table or summarize yourself. When do we use uniform? When do we use binomial? When do we use Poisson? When do we use hypergeometric? When we use geometric? And when you all do this, when you distinguish the difference among these, you will be able to understand the, after geometric we have other things which I'm not going to cover. And so this is about the chapter of uh, 6. And we have assignment quiz. I am going to work on quiz because there are few issues you will get problem. So I'm just rectifying. It will be available by tomorrow quiz. Rest of the things are available on on canvas here. Sorry. So this discrete probability distribution I have to, this is slide here. Discussion, this is quiz. I'm going to work making just rectifying this. Discrete probability distribution, this is mini tab assignment. This is a appendix, or binomial distribution appendix, Poisson distribution appendix. So yeah, this is about chapter number 6. If you have any question, please let me know. If no question, I would like to say have a good night. Practice some of the examples from the book on this. You have odd problems on in the book. All the odd problems answers are given at the back of the book. So please practice odd examples of the book. That will help you help you to um, become expert in the statistics and decision science. If you have no question, I would like to say have a good night. Bye bye. Thank you. Thank you. Bye. Good night. Thank you.